SafeScope is an AI application aiming to assist security forces and protect civilians by detecting illegal firearms in conflict areas. The user-friendly interface allows for easy navigation, and let's walk through how it works. Start by uploading an image captured from a surveillance source. SafeScope will then process the image using its custom-trained YOLO models. The models will then proceed to detect firearms and detect whether the subject is uniformed and whether the subject is actually holding the weapon. Once it processes this information, it will display an output image showing the bounding boxes, the weapons, and the detected individual. It will then give us an alert based on the information it has processed from the image, and it will give us confidence scores for each subject that has been detected by the model in the image. So I'm now going to go over the presentation. We are a team of 4 students who are aiming to improve security in conflict zones and border areas, as this is an urgent challenge due to the constant threat of unauthorized armed individuals. So our vision is to detect illegal weapon possession with context awareness, enable fast alerts and decision making for security agencies, and seek to support faster response times, reduce the human monitoring load for these services, the agencies, and enhance national security and decision making for security purposes. So let's get into what our project does. Our system uses a detection framework based around 2 YOLO models, one trained for detecting guns and another for detecting or identifying military uniforms. So when a gun is detected in a surveillance frame, the system dynamically checks for the presence of an army uniform within the same frame. By using an IOU intersection over union calculation, if no uniform is found or the overlap is below a set threshold, the system concludes that the weapon is likely unauthorized and immediately sends a detailed alert. Okay, so this just outlines the steps of our functionality. We plan on integrating video inputs as well, so security cameras, drone footage. What the model will do is process the video frame by frame and provide the relevant information from each frame. So here I have an example of 3 images. So the first one is signaled as a low threat, since we have an armed personnel who is holding the weapon. The second one is not an armed personnel, but we can see that he's not holding the weapon, so it's a medium threat level. And an output 3, a higher threat level, is flagged, since we can see multiple people and they are not armed and they're holding a weapon. Below you can see the performance of each model. Now our testset has around 2000 images. The 2 nano models for gun and uniform can be used to fully deploy the system on edge devices. That means the drone itself can perform the full detection and only send alerts. So the way it would work is that we use a nano model for the gun and a medium model for the uniforms. This optimizes delay, accuracy, and computational resources. Both medium-sized models can be used for maximum accuracy, but would be deployed on the cloud, increasing latency, resulting in longer processing time, so alerts will come later. Some more ideas we had for future expansion include smarter context detection based on location and time, behavior-based threat analysis. So an AI can flag suspicious behavior even if it's an armed personnel. Cross-camera tracking, so to be able to handle multiple inputs across multiple camera feeds, and recognizing different weapons based on the requirements. Some challenges we faced are extreme conditions like fog, rain, low light, etc. really deteriorate the quality of the image or the video, making it harder for the model to detect uh, weapons and uniform. We also faced ethical issues in terms of handling sensitive data and maintaining fairness. So to conclude, this application uses a YOLO V8 based method for illegal weapon detection in conflict zones, and by using separate models for weapon and uniform detection, the system achieves both efficiency and contextual understanding. Spatial analysis via IOU help distinguish between legal and illegal weapon possession, and the architecture supports flexible deployment for different environments. Thank you for listening.